Hi, today we're going to be looking at multiplying decimals. So when you are multiplying decimals, it is very important to know how to multiply. If you have trouble multiplying, go back to your multiplication facts that was given to you in your first unit with whole numbers. So with multiplying decimals, it is going to be the exact same thing. You're going to multiply the numbers as if you would normally. The important thing to remember is how many numbers are behind a decimal, because the same needs to exist for your final answers. So I have written these in a way so that the decimals are lined up. A lot of times you will see problems like that when people write their work out, they do that just because you tend to line up decimals when you're adding and subtracting. When it comes to multiplying and dividing, that part does not matter as much. Only thing that matters is how much you have in your final answer. So when we are multiplying, our final result will have to have the same number of digits behind the decimal. Now, with the first one, if you were to see how this is lined up and do what you do when you're adding or subtracting decimals, you would most likely want to add a zero here. That is not necessary in this case, but sometimes people do that. Well, how does that change your answer if you do? Well, if you add a zero there, you're going to have 1, 2, 3, 4 numbers behind the decimal. If you don't add the zero there, you only have 3. Your final answer will still be the same. The difference is that if you add a zero here, there'll be a zero at the end. And we'll look at that example. Well, at first, let's do 0.2 times 0.3. Here is a very common mistake that many people make when multiplying with decimals. So when multiplying with decimals, they'll say, I know 2 times 3, that's easy, that's 6, so the answer must be 0.6 because that's 0.2 and that's 0.3. That is wrong. Think about that. If you had 0.2 of something and you had 0.3 of something, or if you had 0.2 of something and you multiply or you took 0.3 of it, would it get larger? Would it become 0.6? Or would it get smaller? Well, if we had 0.2 and we multiplied it by 3, we took 3.2s and put them together, we would get 0.6. But this isn't 0.2 times 3, it's 0.2 times 0.3. So it should be smaller, right? A lot of times when it comes to multiplying with decimals, you need to think about your logical answer and the way that you're mapping to it. Would it make sense for you to get 0.6? No. And that goes back to that number sense. Number sense is very important, especially when doing things that commonly cause mistakes for people. So let's see, how would you do this then? Well, as I said, you multiply as you normally would. And so 2 times 3 would give us 6. So our final answer has 6 in it. Now, the other thing I said is that we need to know how many digits we have behind decimals in our factors. Well, we have 1, 2. We have 2 digits behind decimals in our factors. That means I need 2 digits behind a decimal in this case. But it still should essentially have the value of 6. So I'm going to put my decimal down. If I put a 0 on the end, that would give me 2 digits behind the decimal, right? But essentially, it wouldn't be 6 that I was looking at. That would be 60. So how can I do this so that there's still essentially 6 here? Well, between the decimal and the 6, what I can do is I can add a 0. So 0.2 times 0.3 is 0.06. That makes sense. The answer got smaller. Okay, I feel you. But what about if I had 0.2 times 0.3? How else could I do this so that I know for certain that this really is supposed to be 0.06? Okay, well, remember that you can change from fractions to decimals, from fractions to decimals and decimals back to fractions. We talked about that before. So this will be 2/10. So this would be 2/10. So we would write 2/10. That's how it would be written as a fraction. Okay. This is 3/10. So this would be written as 3/10. Well, when you multiply with fractions, remember it's numerator times numerator, denominator times denominator. So in this case, we end up with getting 2 times 3, which is 6, over 10 over 10 times 10, which is 100. So we would get 600. Well, that's exactly how you read that, right? Okay. So you can do that so that you can also help estimate what your answer should be and to make sure that it's correct. You can change your decimals to fractions, and many times it'll be quite easy to do so. Also, they'll help you see that why we need to have 2 digits behind a decimal, because this is a hundredths place. All right, let's look at the other example. Remember, we're going to look at it doing it this way, and we're also going to look at it when we add a 0. All right, let's begin multiplying. So when we do 6 times 2, we of course get 12. And then for those of you that like to add the 1 on top, I'll do that and carry over to 10. That's fine. So we have now 6 times 3, and that's 18. And so we now add 1, we get 19. All right. Now we're going to move to the 1. So before we do that, we had a 0 here. It's a placeholder. So we have 1 times 2, we get 2. That's no longer there. We get 1 times 3, and we get 3. And we add those up together. We get a 2. We get a 1, 1. We get 5, 12. 32 times 16 gives you 512. So we're good. Well, our final result needs to have 1, 2, 3 numbers behind the decimal. But we have 1, 2, 3 numbers here, so we'll put our decimal right there. And so that's our answer. And if you were to put 3.2 times 0.16 into the calculator, you would see that you would get 0.512. Okay. Well, let's see what happens. We'll see if what Mr. Stevens said was correct earlier by adding a 0 in the end. So if you do this, you get 6 times 0, which is going to give you 0. You get 6 times 2, which gives you 12. You put your 1 up there. 6 times 3 gives you 18, plus 1 gives you 19. We got a 0 down here. 1 times 0 will give us 0. 1 times 2 will give us 2. And 1 times 3 will give us 3. And we add those up, we get 0. We will get 2. We will get 1. Another 1 added to the last place here. We get 5. And so, oh, that's 5. That's 5,120. That's not 512, Mr. Stevens. Well, I did say we have to count how many digits are behind the decimal. And now that we add the 0 here, we have 1, 2, 3, 4 digits behind the decimal in our factors. So in our answer, we should have 4 digits behind the decimal. Well, if we have 4 digits behind the decimal, that would go here. But those don't look the same. Remember, you can add as many zeros as you want at the end, or you can remove zeros at the end so that they have the same value. The only reason why we want to keep zeros there would be for significant figures, which you'll see soon. All right, so when multiplying decimals, very important to remember, you just multiply it. The only thing that you have to do differently is in your final answer, go back to your factors and see how many digits are behind a decimal. Make sure your final answer has that same number of digits behind the decimal. A lot of times what people will do is when they get to this result, they move the decimal. So it's 512, so they would move from here and go over 1, 2, 3, because it's 3 digits behind the decimal, so they know that in their final answer, the decimal should be here. Same thing here, they would start here 1, 2, 3, 4. With the example we had earlier with just a 6, and we need to move 2 times, they would go 1, 2, put their decimal, so they know that this empty hole needs to have a 0 in it as a placeholder. All right, that is multiplying decimals. Multiply as normal. Count how many digits are behind the decimals in the factors. Make sure the answer has the same number of digits behind the decimal in the product. I will see you soon.